Hey everyone, and welcome to The Explainer. Today, we are exploring what is literally the backbone of major modern infrastructure. We're doing a deep dive into the supply, the specifications, and the logistics of Titanium Grade 2 for major Iraqi infrastructure projects, all sourced directly from the experts over at Alloy 360. If you've ever wanted to understand the absolute nitty-gritty material science and the incredible global logistics that go into the massive rehabilitation of the energy and chemical sectors, well, you are in exactly the right place. Let's get into it.
Just look at the sheer scope of this operation. We're talking about a massive high-performance inventory here. They've got a comprehensive range covering titanium grades 1 through 5. Then there's a full heavy-duty nickel alloy lineup. I'm talking the Inconel series, Monel 400, Hastelloy, and Incalloy. And on top of all that, specialty stainless and duplex steels like 904L and Super Duplex 2507. It is a vast catalog. And the best part is, it's all supported by live price and Knowledge Hub access so you aren't flying blind.
So here is our roadmap for today. We'll start with suppliers and pricing, move into formats and applications, dig into the technical profile, do a quick titanium grades comparison, walk through the fulfillment process, and wrap it all up with some frequently asked questions.
All right, let's jump right into Section 1, suppliers, stock, and pricing.
Alloy 360 is operating on a truly global scale. They're headquartered right in Milan, Italy, but they run a massive regional hub out of Shenyang, China, and from there, they're dispatching materials regionally to Basra, Baghdad, Erbil, and Qasr in Iraq. You can actually reach out to their sales team directly at sales@alloy360.it. Now, this international supply chain, it's absolutely vital. Why? Because commercially pure Grade 2 titanium is the essential go-to material for these incredibly aggressive industrial environments. It's specifically chosen because it can withstand the blistering high temperatures and highly saline water conditions that would just completely chew up and corrode standard metals.
Now, you might be wondering, how do we even price this stuff? Well, budgeting for this material isn't just one static number. It's a journey. It starts with the base price of raw titanium sponge on the international metal markets. Then you have to factor in the processing and fabrication specs to get the exact shapes you need for construction. Next up is the physical journey itself: sea freight into Qasr port, border customs fees, and overland transport insurance. And finally, if you're talking large project volumes, like outfitting an entirely new refinery or power plant, that scale can unlock some serious direct mill-aligned pricing discounts.
Moving on to Section 2, let's look at the actual formats and where this material gets put to work.
Their physical inventory covers a really wide array of formats. For sheets and plates, which are all produced under super strict international safety standards, like ASTM and ASME 265, the thicknesses go from just 0.5 millimeter all the way up to a really chunky 50 millimeters. And the sizes? Huge, up to 2,000 by 6,000 millimeters. You can get these as cold-rolled, hot-rolled, or custom-cut blanks. Then you have the round bars and billets. These range from 6 to 300 millimeters in diameter, cut to 3 or 6 meter lengths with precision sawing, and they come in finishes that are ground, peeled, or bright polished. But wait, there's more. The stock also includes seamless and welded pipes. We're talking sizes from a 1/2 inch up to a 12-inch nominal bore, across schedules 10s, 40s, and 80s. And they include all the matching standard fittings and flanges. Now, to actually join all this together, you need welding rods and wires, available in 1.6 to 3.2 millimeter diameters. And here's a brilliant little engineering detail. These rods are sealed in 5-kilogram plastic packaging specifically to lock out moisture and prevent hydrogen contamination. This is absolutely critical, because if titanium is exposed to hydrogen during welding, it becomes brittle and cracks. No one wants a cracked pipe in a chemical plant, right? So how do these formats translate into real-world impact across Iraq? In oil and gas refining, this titanium is literally the stuff building heat exchanger tubes and condenser bundles in the major facilities in Basra, Baiji, and Kirkuk. In power generation, they use it for massive steam condenser systems that have to handle raw, brackish river water. For water desalination, it is basically mandatory because it can handle highly saline groundwater and direct sea intakes that would cause standard stainless steel to fail rapidly. And in chemical processing, it lines massive reaction vessels and transfer lines handling some seriously aggressive corrosive acids.
Okay, Section 3, technical profile and benefits. Let's get a little microscopic here.
To be used in critical chemical and pressure installations, this inventory has to meet ridiculously strict international benchmarks. We're talking the American ASTM and ASME codes, specifically B265, B348, and B861. Plus, you have the European and Japanese equivalents, like DIN 37035 and JIS H460 Class 2. And the kicker? Every single piece is heavily certified under EN 10024 3.1 standards, so you have 100% full material compliance. There's zero guesswork.
Looking at the actual chemistry, it's all about purity. You've got a massive 99.2% minimum titanium balance. The tiny fractions left over are strictly capped trace elements. Iron is cut off at a max of 0.30%, oxygen at 0.25%, carbon at just 0.08%, nitrogen at 0.03%, and hydrogen, it maxes out at a genuinely microscopic 0.015%.
And what happens when you combine those strict chemical limits? You get exceptional structural integrity at room temperature. The yield strength, which is the point where the metal permanently bends, is a minimum of 275 megapascals. The tensile strength, the point where it literally snaps, starts at 345 megapascals and can reach up to 480. Plus, it has an elongation of at least 20%, which means it retains great ductility and can stretch significantly without fracturing. All of this, by the way, while maintaining a remarkably low density of just 4.51 grams per cubic centimeter. It's light, but it's incredibly tough.
Oh, and if we're talking about extreme environments, 1660 degrees Celsius. That is literally the melting point of this material. It is fundamentally engineered to just shrug off incredibly demanding thermal conditions.
So what does all this data actually mean on the ground? Operationally, it translates to outstanding resistance to wet chlorine gas and marine biofouling. And remember that density we mentioned? It means this metal is just 60% the weight of standard stainless steel while maintaining incredible structural strength. Plus, it's got excellent weldability using TIG and MIG methods. On the supply side of things, Alloy 360 provides genuine mill traceability with unique heat numbers, which is basically a birth certificate for every single batch of metal. Combine that with in-house precision water jet and saw processing and heavy-duty wooden crates for overland transport, and you've got a seriously reliable supply chain.
Section 4, let's do a quick titanium grades comparison to see why Grade 2 is the star of the show.
When you line up the commercially pure options side by side, the trade-offs become really clear. Grade 1 gives you the absolute highest purity and excellent formability for deep drawing, but it has a lower tensile strength, starting at 240 megapascals. Now look at the other extreme, Grade 4. It provides industrial-level purity and huge tensile strength at a minimum of 550 megapascals, great for high-strength fasteners and valve bodies, but its formability is quite limited. Grade 2? It hits the absolute sweet spot. High purity, a solid 345 megapascal minimum tensile strength, very good formability, and 20% minimum ductility. It is quite literally the optimal Goldilocks choice for things like seawater piping and pressure vessels.
All right, Section 5, fulfillment and delivery process. How does this metal actually get to the job site?
The logistics journey here is a very precise 4-step flow. Step 1 is your RFQ submission. You send over your bill of materials and their estimators review it for a commercial quote. Step 2 is quality verification. They actually go in, pull the specific heat-numbered materials from inventory, and verify those mill test certificates. Step 3 is material cutting and packaging. They cut the materials to spec in-house and pack them into secure wooden crates treated to ISPM 15 standards, which is a strict international standard for pest control in shipping wood. Finally, Step 4 is customs clearance. The logistics team prepares all the regional trade documents to ensure smooth, delay-free transit directly to Basra, Baghdad, Kirkuk, or Erbil.
And finally, Section 6. Let's run through some rapid-fire frequently asked questions. The source material has a great FAQ section covering some key logistical and standard questions. First off, transit times for stocked materials to Basra, usually just 3 to 5 business days from their regional warehouses. Do they do custom profiling? Yes, high-precision CAD systems can cut plates up to 50 millimeters thick. What's the deal with ASTM versus ASME? Basically, ASTM is your base material specification, while ASME is the equivalent standard specifically adopted for pressure-retaining components. Can you bring in a third-party inspector? Absolutely. They regularly host Bureau Veritas, TUV, SGS, and Lloyds. And as for marine environments, Grade 2 is reliably tough in seawater up to roughly 75 to 80 degrees Celsius. Continuing with procurement. Is it sour service compliant? You bet. It complies with NAC MR 0175, which means it operates safely in highly toxic hydrogen sulfide-rich oil and gas environments without cracking. Sheet finishes come in 2B, No 1, and polished. There are no rigid minimum orders for standard in-stock items, which is super flexible. For transport, those sheets are safely interleaved with protective paper or a thick polyethylene film so they don't scratch. And lastly, to summarize why Grade 2 usually wins out over Grade 1, it just provides significantly higher mechanical strength while keeping that exact same incredible corrosion resistance and ductility.
And that wraps up our deep dive into the source material from Alloy 360. You now have a comprehensive, highly informed understanding of the exact specifications, logistics, and pricing drivers for titanium Grade 2. It's pretty amazing, right? The next time you see a massive desalination plant or a refinery upgrade taking shape, you'll know exactly the microscopic chemistry and the complex global logistics holding the whole thing together. So, with this framework in your back pocket, what massive engineering challenge are you going to solve next? Keep learning, stay curious, and we will see you in the next explainer.